Hi, and welcome to Lesson 4.01, Chemical versus Physical Changes and Properties. The lesson objectives: a physical change or physical property is one that affects only the properties of that substance. Physical appearance is altered, but the composition remains unchanged, which means your chemical is still the same chemical. Water is still water. Lead is still lead. You have not turned lead into gold, and you have not turned water into carbon dioxide. Okay, so those bonds are still intact. A chemical change actually changes those bonds. Water is no longer water after a chemical change. It is no longer H2O. So that molecular level, those bonds, the ionic and covalent bonds, have now been destroyed. That's a chemical change. The change is actually the act of transforming. You might hear us say physical change, physical property. Chemical change, chemical property. Not a lot of difference between a change and a property, other than change implies the act of transforming, property means the ability to do something. But just because something has a physical property doesn't mean it's actually doing it right now. So that's the difference between change and property. Physical. Let's compare the changes and properties and identify some physical changes and properties. Physical changes are like breaking, melting, freezing, boiling, dissolving, condensing, bending. You kind of notice how those words imply that something's happening right now? You know, I'm freezing water. Well, that means that I'm freezing water right now, so I'm changing it. It's actually undergoing the change right now. Notice the words breaking. If you break something like a piece of glass, you have not altered its molecular composition. It's still the same molecules if you look at it under a microscope. They're just broken off from each other. Melting. If you melt something, it's still the same chemical. If you take an ice cube out of the freezer and stick it on the counter, you're going to have a big mess, but it's still water. You didn't turn it into something else by letting it come to room temperature. Same thing with freezing and boiling. When you dissolve something, now this one a lot of students don't know. When you dissolve something, it is actually a physical change. When we dissolve salt in water, salt, it's still salt, it's still NaCl, it's just dissolved, it's just mixed in the water, but it's still salt. We didn't turn it into an atom, we didn't turn it in, to like a regular atom, sodium atom by itself. We didn't turn it into magnesium, we didn't turn it into a whole new chemical altogether, sodium hydroxide. It's still NaCl, it's just dissolved, it's still salt. Some properties are color. The color of your substance is a physical property. The freezing point, boiling point, melting point, things like that. Water boils at 100 degrees Celsius. That's a physical property. Magnetic attraction, if something is attracted or not attracted to a magnet. Malleability, solubility, if something's able to dissolve. Odor, if something smells. Not that you're forming an odor, but just does something have an odor. Ductility, opacity, viscosity, shape, and of course density. We know what density is, mass divided by volume. That is a physical property. Water's density is 1 gram per milliliter. That's a physical property. Now when we have physical properties, we can classify them as either extensive or intensive. Extensive means that they do depend on the amount of matter. They do depend on the amount of matter. And so an extensive is some examples are going to be mass, length, and volume. Mass, if I were to measure the mass of a substance, does it matter how much I have there? Yeah, absolutely. The more I have, the more mass I'm going to have. Length, does that matter how much I have? Absolutely, because the more I have, probably the longer it's going to be. Those things are extensive. Intensive properties are those properties that don't matter how much you have. For example, the density of water is 1 gram per milliliter. If I have 1 cup or 5 million gallons, is the density of water still 1 gram per milliliter? Yes. The density of water does not change depending on how much you have. The density of water is 1 gram per milliliter if you have 1 cup or a million gallons. How about the boiling point of water? Water boils at 100 degrees. Does it matter how much you have? No. If you have 1 cup of water, put it in a pan, it's still going to boil at 100 degrees. If you have 10 cups of water in a pan, it's still going to boil at 100 degrees. Now, it might take longer for it to boil, but that's not what we're talking about. We're not talking about time. We're talking about, does it matter to change the property? Boiling point of water is 100 degrees. Doesn't matter how much you have. It always boils at 100 degrees under normal circumstances, of course. If you have 1 cup or 10 cups. 10 cups, of course, are going to take longer. All right, so that's it with the physical properties and changes. Chemical changes. Remember, chemical changes are about chemically changing that composition. The changes are rusting, reacting, like your chemical reactions, burning. Anytime you burn something, you are changing that chemical composition. Baking or cooking. Anytime you bake or cook, and actually bake or cook something, you are changing that chemical composition. You cannot uncook something. You can't go back. Like when you melt something, that's a physical change. Once you melt it, you can refreeze it. Once you bake something, you can't unbake it. It's done. It's changed. It's chemically changed. Some properties are heat of combustion, probably something you're not familiar with yet. Oxidation state, which you're going to learn all about oxidation state in a little while, and that has to do with the electrons and how many electrons it has. Reactivity with water, you're going to learn a lot about that in Module 4 here soon. pH, pH is a measure of the concentration of hydrogen ions. You're going to learn that in second semester. Reactivity in general, so chemical reactions, which all of Module 4 is about. And flammability, can something burn? Does something have the ability to burn? That's the property. You have the ability. And then changes is the actual act of burning. So you name it. On your sheet of paper, if you can write down these examples, and then I want you to classify it as either physical or chemical. And then if it's physical, indicate if it's extensive or intensive. I put E and I to represent it because that's what I'm going to be putting here. I'm going to be putting PE or PI or C. Magnesium burning in air. Our operative word is burning. Burning indicates a chemical change, therefore this is chemical. A piece of wood sawed in two. Sawed is the operative word. Sawed, we're just cutting it, so cutting, breaking, that's all going to be physical. For wood to be able to cut in half, does it matter how much we have? Not at all. Therefore, this is an intensive property. So it's physical and it's intensive. See salt dissolving in water. Our operative word is dissolving. Dissolving is a physical property. It's a physical change, being able to dissolve. And does it matter how much salt I have to have the ability to dissolve? Not really. Keeping things simple, under normal circumstances, it does not matter how much substance we have. So that's an intensive property. Milk turns sour. So this has two operative words. Turning sour is a chemical change. Bread rising. When bread is rising, that means there's a chemical change going on inside because we are baking it. Therefore, it's chemical. Water has a density of 1 gram per cubic centimeter. That is a physical, and this does not depend on how much I have, therefore it's intensive. So what's next in progress? So thank you so much for joining us today, and I hope you've learned a lot about physical and chemical changes and properties, and we look forward to seeing you in the next lesson.